Fine. Our group is conformed by Adrián Valdelamar, Melanie Padilla, Llach, and me, Daniel González. And we are going to explain the second laboratory of the class.
Well, firstly, I will explain the operation of the circuit. We first play the common emitter amplifier that generate the voltage gain, and then we will have the common collector that generate the current gain. The other is that to the fact that the common emitter will provide us with the amplifier signal and with a high output impedance, will the common collector configuration ensure that the output impedance is low and greater current gain is produced. So in this way, to avoid the effect on load, we also review according to the assigned condition the value we have short frequencies, input voltage, output voltage, and this way we assigning corresponding values to the resistance and capacitance.
Well, the input signal is applied at the base of the BJT transistor, and the output signal is located at the collector of the BJT transistor, as the amplifier is common emitter. The input signal is amplified approximately by a factor of 5.2 volts over volts. As you can see in the simulation, the output signal has a phase displacement of 180 degrees from the input signal. This means that when the input signal arises, the output signal decreases, and so on.
Well, I'm going to explain the first part of the process to find the values of the elements of the amplifier circuit, which, as said before, is the common emitter model. First, we have to take into account the data we have, which are the source frequency, the input voltage, the output voltage, the load resistance, and the source resistance, to find the other values. Then we have to choose a transistor. In our case, we select a commercial BJT, the 2N2222, and we look for its datasheet to make assumptions that will happen in reality. We also choose a 15-volt power supply for the amplifier circuit. With this in mind, we start to make the assumptions. First, we have to assume that the maximum collector voltage that could exist by the voltage divider that can be seen in the circuit is half the source voltage, that is 7.5 volts. In the same way, the same is done with the maximum collector current, that comes to be 5 milliamps. And thus, being guided by the datasheet, it can be established that the base current will be approximately 25 microamps. Within all of this, the beta established for the transistor by LTSpice is fulfilled, which is 200, and the voltage that is dropped in the transistor that registered LTSpice, which is 0.708 volts. These two data are present in the datasheet, and this is how we make the DC analysis and make a little assumptions.
Once we have gotten all the values from assumptions done before, we proceed to calculate the values of resistor 1, 2, C, and E. Those are obtained using next expressions, and notice that we use the VCC voltage as a feed. We use the voltage from emitter, base, collector, and their respective current. Using these values, we got this improved model with more conventional values for resistor and 2 and E. We use it because this is more commercial value and is better for implementation. Our AC analysis is done knowing the output voltage is 5 volts, the thermal voltage is 25 millivolts. Our interest over here is to find the output resistors, this current shown here. The AC parameters went done the same way using these expressions. And our improved AC model was this, where more commercial voltage for signal resistor used this in the circuit. Our capacitors values were found knowing that the capacitors are supposed to bypass the DC, so they must have less than 1% capacitive returns. Knowing this, that we found these values, which later we would improve in a complete model that turned out in this, and where our output voltage is 5 0.12 volts. This is our final circuit.
In the second activity, in general, what we do is a two-stage circuit which allows us to amplify with a common speaker the signal that comes from a common microphone. For this, we decide to use the amplifier circuit model B, seen in class, for the good amplification that this produces in relation to the other models. The values taken into account for the speaker and the microphone were such that the condition of amplifying the signal so that it was heard up to at least 5 meters was theoretically fulfilled.
In the first stage of the amplifier, we have a common emitter BJT configuration. This BJT transistor, Q1, is biased using R1 and R2 resistors. These two resistors create a voltage divider bias. The input signal is applied at the base of the transistor, and the output signal is taken from the collector. This output signal supplies the second stage of the amplifier. Now I'm going to run a simulation to see the amplification of Q1. This is the input signal, and this is the output signal.
In the second stage, we can see that we have two types of transistor. One NPN working with a positive cycle, and the other PNP working with a negative cycle. They both need their collector current to be greater than 0.6 to amplify. Now in the simulation we can see the input signal and the output signal and see how is the amplifier signal.
The circuit is strictly based on the B model. The structure consists of two stages with three BJT transistors, two 2N2222 NPN and one 2N2907 PNP, which beta are 190 and 100 respectively on the realistic models, but for this case they will have 200 and 250. We can say the properties of the B model are that it dissipates less energy, but it is certain that it can present little distortion, what makes it a not so reliable model sometimes. Talking about the gain amplifier, we notice that this is 6.26 volts per volt, and this is due to the low resistance in the low resistance which is over here. The main purpose is done successfully. The resistor values were just selected with commercial ones. Here we see that the highest values used is 12K ohms. And continuing with the diodes, they are here to lower the voltage base to create a difference between this base, the Q2 base and Q3 bases. The models are for this both are 1N 4148. This voltage drop is approximately 0.64 volts, which is a really good one for the purpose of this practice.